Hello everyone. In the last lecture, we have discussed the SN1 reaction. Today, I am going to talk about the mechanism of SN1 reaction. Before we start the mechanism of SN1 reaction, what is a SN1 reaction? SN1 reaction is the nucleophilic substitution unimolecular reaction. Nucleophilic substitution of unimolecular reaction. The example of SN1 reaction is the tertiary butyl bromide reacts with the sodium hydroxide or potassium hydroxide. Tertiary butyl bromide reacts with the potassium hydroxide or sodium hydroxide, then to formation of tertiary butyl alcohol plus potassium bromide. Now the kinetics of this reaction, the rate of reaction depends only on the concentration of reactant. Depends only on concentration of reactant, not depends on the concentration of nucleophile. So the SN1 reaction is a first order nucleophilic substitution reaction. It is a two-step mechanism. In SN1 reaction, there are the two-step mechanism. Okay. In a step one, the ionization of the tertiary butyl bromide, ionization of the tertiary butyl bromide, and in second step, the attack of nucleophile on the carbocation. In second step, the attack of the nucleophile on carbocation. Let's see the step number one, the ionization of tertiary butyl bromide. Ionization of tertiary butyl bromide. Now, the first step is a slow step. This is called as a rate determining step. The first step is a slow step. This is called as a rate determining step. In this reaction, the bond between the carbon and the bromine is a break. The breaking the bond between the carbon and halogen, then to form the carbocations, because the bromine has a more electronegative than the carbon. So bromine, which withdraw the electron density from the carbon atom, so get here the bond is a carbon halogen is a polar bond. Okay, in a slow step, the this bond between the carbon and halogen is a break. Okay, then the formation of the transition state. Then the formation of the transition state. In the transition state, the bond, that is the dotted line, shows the bond between the carbon and bromine as a broken. As a broken. The bromine carries a partial negative charge and carbon carries a partial positive charge. The three methyl groups which is attached to the carbon atoms, okay, the three methyl groups of tertiary butyl bromide, this is a sterically hindered the approach of the nucleophile. When the nucleophile is attached on the carbon atom, these three groups are the sterically hindered of the nucleophile and then prevent the backside attacks. Therefore, in the first step, the carbon bromine bond ionizes to give the carbocation. In the first step, the bond between the carbon and bromine has ionizes to give the tertiary butyl carbocations and the bromide ions. Due to the gradual breaking of the bond, a transition state is a form. In the transition state 1 is mentioned here the breaking of the carbon and bromine bond, the electron donating inductive head means CSP group has a electron donating donor group. There are the three methyl groups. There are the three electron donor groups which stabilize the carbocations. In a step 1, the ionization of the tertiary butyl bromide, then to form the carbocation, tertiary carbocation. In the step number 2, the attack of nucleophile on carbocations. The attack of nucleophiles means OH minus on carbocation. There are the two possibilities of attack of nucleophiles: front side attacks and back side attacks. Front side attacks on tertiary carbocations and back side attacks on tertiary carbocations. When the nucleophile is attacked from the front side, when the OH minus is attached from the front side, then the retention of configuration is formed. The retention of configuration is formed. This OH is attached from the same side of the bromine group. OH minus is attached from the, that is a OH minus group is attached from the same side of the bromine group. Okay, that's why here the retention of configuration is formed. When the nucleophile is attached from the back side to the carbon atom, then that time the inversion of configuration is formed. The inversion of configuration is formed. Means the front side attacks result in the product retention of configuration. However, the back side attacks result in the product with the inversion of configuration. Since the attack from the either sides is both front side and back side, there will be the retention in 50%. Retention of configuration is 50%, and inversion of configuration is the 50% in the molecule. 50% in the molecules. Now, the energy profile diagram is obtained by plotting the energy profile diagram is obtained by plotting the potential energy against the reaction coordinate. Potential energy against the reaction coordinates. In this figure, there are the two humps. Okay, in this figure, there are the two humps. Okay, there are the two peaks are observed in this graph. The potential energy is along the y-axis and the reaction coordinate along the x-axis. When this is the SN1 reaction is a two-step mechanism, two-step reaction. In the first step, when the nucleophile is reacts with the tertiary butyl bromide, okay, the carbocation is formed. Tertiary butyl bromide is a reacts with the nucleophile, then to form the carbocation is formed. Tertiary butyl carbocation is formed. In the second step, what happened? In the step number 2, the OH minus is attached from the front side and the back side, then to form the tertiary butyl alcohol, then to form the tertiary butyl alcohol plus bromide ions. Means in this figure, there are the two humps are formed. Now, what is the energy of activation? Energy of activation is the energy that must be supplied to the reactant in order to form transition state. The energy which is supplied to the reactant then to form the transition state. It is equal to difference in the potential energy of the reactant and the transition state. The first, the EA1, this is the energy of activation, EA1. It is a difference between the potential energy of the reactant and the energy of the transition state. Okay, transition state. And this is the another difference is that this is the energy of activation here also given. Okay, EA2. Now it is a difference in the potential energy of the reactant and the transition state. The step number 1, the step 1 has the highest activation energy. The step number 1 has the highest activation energy. Step number 1 has the highest activation energy, and hence it is a slow step. Okay, the step number 1 is a slow step reaction, and the step number 2 has a lower activation energy. Step number 2 has a lower activation energy, so it is a fast step reaction. There are the two steps in a SN1 reaction. The first step is a slow step reaction and which has the high activation energy, and the second step is a lower activation energy, and hence it is a fast reaction. Means In this figure, EA1 and EA2 are the energy of activation for the step number 1, and EA2 is the energy of activation for step number 2. And this is here the delta H. The delta H is given, that is a heat of reaction. Delta H is a heat of reaction. It is a difference of the potential energy of the reactant and the potential energy of the product. This is a multi-step reaction. There are the two-step reaction. The slow step determine the overall the rate of reaction. The slow step is a rate determining step, a rate controlling step. The first step, that is called as a slow step reaction. Okay, and the second step has the fast reaction. Second step has a fast reaction. In the slow step, only tertiary butyl bromide take part, and not the nucleophile. In the slow step reaction, only the tertiary butyl bromide is used. Okay, take the part in the reaction, not a nucleophile. So it is a first order reaction. So it is called as a first order reaction. That means the rate of reaction, which is depends only on the concentration of the tertiary butyl bromides, not on the rate does not depends on the concentration of the nucleophile. Okay, is in a step 1 only one the tertiary butyl bromide take part in the reaction, not the nucleophiles. Okay, so the SN1 reaction, in this reaction, the tertiary butyl bromide is a reaction with the sodium hydroxide or potassium hydroxide. Then the formation of the tertiary butanol. Okay, tertiary butyl alcohols. Now, today we stop here. Thank you.